Welcome to another Forge College Explainer. Grab your lab coats and your magnifying glasses because today we are going full CSI on an Ethereum transaction. We're going to simulate and observe transaction execution, taking all the preparation work we've done and throwing it right into the testing lab to see exactly how it behaves. We are dissecting the digital footprint of Web3 to see what actually happens under the hood.
Here is our agenda for the day. We'll start with number 1, where we left off. Then 2, choose your simulation path. 3, gathering digital evidence. 4, deploying the AI assistant. 5, passing final inspection. And 6, looking ahead to finality.
Let's kick things off with section 1, where we left off. So you just survived the grueling work of configuring your testnet environment, and honestly, congratulations on that. You've got your wallet keys, your testnet endpoints, and your observation checklist all ready to go. Now it's time to put those carefully crafted tools right into the simulation matrix. This is where the theory we discussed in the life cycle of an Ethereum transaction course actually meets reality. We are stepping into the capstone project simulation, moving away from all that setup and diving straight into the execution phase.
Now, the absolutely crucial point here is that this signed transaction isn't just theoretical anymore. It is the prime suspect we are throwing into our lab for testing. Think of it as pure digital DNA. It's the exact prepared script that we're going to interrogate so we can capture its execution traces and figure out exactly what it does when executed. Every parameter, every signature, and every data payload is locked into this raw transaction, just waiting to be unpacked and examined in our simulated environment.
Moving right along to section 2, choose your simulation path. You actually have two very different ways to run this experiment, and it entirely depends on your needs. Option A is the RPC tracer. This fires off debug trace transaction on an archival node. It's fantastic for seeing how your transaction reacts in a shared, live, and slightly unpredictable testnet environment. Option B is your local fork, using tools like Hardhat or Ganache. This doesn't broadcast to the network at all, which means you get an isolated, highly repeatable environment. Both are completely valid. It just depends on the specific conditions you want to test. If you want absolute, deterministic replay without any external noise, Option B is your best friend. But if you want to see how your code interacts with a live testnet state, you'll definitely want to go with the RPC tracer path.
Next up is section 3, gathering digital evidence.
You need to set up this exact directory blueprint to ensure our capstone evidence bundle is perfectly organized. We definitely don't want a messy lab bench here. Step 1 is creating your raw folder for the heavy JSON trace files. Step 2 is setting up the metrics folder for the easily readable CSV or markdown data. Step 3 gives you a notes folder specifically for your annotated checklist, and Step 4 is the summary folder for the outputs from your AI assistant. If you stick to this strict sequential blueprint, navigating your data will be an absolute breeze later on when it comes time for the final audit.
Now, what's really interesting about this trace file, which lives right in that raw folder we just created, is that it acts as the micro-level footprint of exactly where our transaction went. This raw JSON evidence, which is usually named transaction-demo.trace, contains every microscopic detail. I'm talking about the low-level opcodes, the internal calls, and the stack dumps. If your transaction sneezes, it gets recorded in the execution trace. This is the very heart of our forensic investigation, laying bare the absolute truth of the execution.
Think of this as your lab results map. It connects the raw opcode evidence directly to human-readable metrics. You can see how the heavy, dense trace file gives us the path and the raw evidence. But let's be real, nobody wants to read millions of lines of JSON all day, so we parse that out into our metrics CSV file. This gives us the high-level summary, the transaction hash, the gas used, the status, and the block number, all of which allows for rapid verification. By linking these two artifacts together, you get both the extreme granular detail and the quick, digestible finality indicators all in one place. And a major contributor to those metrics is the receipt. You'll extract data from the receipt to prove whether the transaction survived the simulation, scoring a status of 1 for success, or if it flatlined on the operating table with a revert status of 0. It is essentially the final heartbeat monitor for your transaction execution. A successful heartbeat gives you a 1, meaning your code executed exactly as intended. A 0 means something went critically wrong, and you need to dive back into the trace file to figure out why.
Let's move on to section 4, deploying the AI assistant.
Combing through trace JSON files manually can literally make your eyes cross, so you will use a starter prompt to feed a slice of your trace to an AI, asking it to sniff out any strange anomalies in the code. You definitely don't need to feed it the whole massive file, just the most relevant slice, to generate a clean, readable summary text file. This saves hours of manual debugging and lets your digital assistant do the heavy lifting of pattern recognition on those incredibly dense execution paths.
But we have very strict quality control for robotic lab partners. For the AI output to be considered valid evidence, it can't just guess. It must explicitly point to exact opcode indices and receipt fields. It has to be concise, ideally just 3 to 6 sentences. If it spots unexpected gas usage or missing logs, it can't just say, something is wrong. It has to say, there is an anomaly at opcode index 324. We need hard, actionable coordinates for our review. Think of yourself as the lead scientist here. You demand precision from your team, and your AI assistant is absolutely no exception.
Which brings us to Section 5, Passing Final Inspection. Your capstone on it is the ultimate gauntlet. Let's go through the checklist. Your trace file has to be present and parsable as valid JSON. Your checkpoint metrics must be recorded perfectly. Your observation checklist needs to be fully annotated. Your AI summary must be generated to our exact standards. And all artifacts must be properly organized in that folder structure we discussed earlier, complete with a detailed README file that guides anyone else through your work. If any of these 5 checkpoints fail, you must head back to the lab, tweak your parameters, and rerun the whole simulation.
I really want to emphasize this checklist step because it is where most scientists trip up. Your annotated checklist needs hard proof. That means every pass or fail grade must point directly to a line in your trace data. You can't just say a checkpoint passed and call it a day. You have to write pass, and then include a 1-line justification explaining exactly where in the trace or metrics you found the evidence to support that claim. This turns a simple assumption into an irrefutable fact.
Finally, Section 6, Looking Ahead to Finality.
By adopting these 3 lab habits, you will dramatically reduce surprises and build highly auditable, responsible debugging records. First, always treat those raw JSON traces as your absolute primary source of truth. Everything else is just derived from them. Second, connect every single CSV metric back to a precise trace location, just like we did in our checklist. And third, prioritize reproducibility. Log your exact commands. Note your environment variables. If someone else, or even you 6 months from now, needs to run this exact simulation again, they should be able to replicate it perfectly based on your notes, without second-guessing a single variable.
And that brings us to the ultimate question. Are you ready to confirm finality? Because in the next lesson, we're going to take everything we've meticulously organized here and move from simulation to actual testnet execution. Thank you so much for joining me for this Forge College Explainer. I hope you're leaving with a clear strategy for gathering your transaction evidence. Be sure to visit forge.college to continue your Web3 journey and explore the rest of our courses. Stay curious, keep building, and I will see you next time.